I've created a new drainage behavior that should be helpful in modeling base sanitary flows. In the past, I've created some drainage behaviors that make it possible to uh, do things like take flows at a node where a model has been calibrated, like maybe an I&I model, to take the flows at that node and then distribute those flows to upstream parcels based on some kind of parcel parameter like water usage. Then from there, those flows could be taken from the parcels and put back to the nodes in the upstream network. And the flows at those nodes could then be exported to a hydraulic model and could be modeled in that fashion. The problem is that sometimes you're going to wind up with a lot of nodes when you take that approach, because you're basically going to have a new loading point or a new place where flows are being assigned to your hydraulic network every time you've got flow to a parcel that drains to a node. And so you could just have a lot of those, and it's almost like the way it would be in the real world, because in the real world you've got a lot of connections from different properties into the sewer system. But in reality, well, from a modeling perspective, it may be easier, though, to not try to model all of those connections, but to consolidate them. And so maybe grouping a number of those nodes together and then loading the flows from those several nodes into one node instead. Okay, so I've created a new drainage behavior that makes that possible. And I'm just going to demonstrate that drainage behavior. So I'm going to open up an existing work group. And let me show you, I've got a wastewater model created here that has a couple of different sets of flows, a couple of different flow groups already. I've got one for base sanitary flow, one for RDII. And I just want to recap real quick how the base sanitary flows works. We've got wet wells, flows at wet wells that get distributed to the upstream parcels using this drainage behavior. We've got flows at the parcels that get distributed to nodes. And then we've got a final drainage behavior that takes the flows from those nodes in that this is an extensive hydraulic network called Picasso all pipes, which basically is the whole system. This last drainage behavior basically takes the flows from the nodes in that full system and applies them to nodes in a smaller subset of that system, which is called the Picasso local hydraulic model network, or Picasso LHM network. Okay, so and for RDI, I'm taking the flows from wet wells, distributing them to upstream pipes based on inch diameter miles, and then I distribute the flows from those nodes in that extended network again to the subnetwork, which is the Picasso LHM network. One nice thing about the way this RDII done is the way this RDII loading happens is that flows aren't applied at every node; they're applied at every few nodes, depending on what kind of threshold you set for creating new loading nodes, and it's based on inch diameter miles as the algorithm walks upstream from that wet well node. So we're basically trying to get this kind of functionality combined with this functionality that I'm using for the base sanitary flows, which is actually applying things at just a lot of nodes right now. What we want to do is consolidate those. So I've created a new drainage behavior that makes that possible. And you can create one by going to drainage behaviors, create, and then nodes to upstream nodes based on parcel attributes, and consolidation based on inch diameter miles. Sorry, it's a mouthful, but I wanted to be descriptive. So I'm going to go ahead and select that, create it, and I'm going to call this wet well flows to upstream consolidated nodes. I'm going to go and view it. So to use this drainage behavior, you need to specify a parcel to node drainage behavior so that the connection between the parcels and the nodes is understood. So I've got one already called parcel to nodes. You need to say what parcel attribute you want to use in distributing the flows to the parcels from your downstream wet well node. And I'm going to use water usage. And then you need to specify the threshold for creating new nodes or consolidated nodes. So, in this case, every 2-inch diameter miles, a new consolidated node will be created. So I'm just going to save that. I'm going to go back to my wastewater model. I'm going to add a new flow group. And I'm going to call this one Consolidated Base Sanitary Flow. Say OK. Now I've got this turned off, and I've got the RDI turned off, and I've just got this one turned on for now. I probably wouldn't want to use both of these at the same time because I would be double counting flows. So I'm just going to leave that one off. And I'm going to use an existing loading behavior I've created called simple flows, which just assigns some very basic flows to nodes in the Picasso all pipes network, which is that extended network. And now I'm going to use some additional drainage behaviors to take the flows from those nodes and to distribute them upstream to upstream nodes in the fashion that I just described a few minutes ago. So I'm going to add this drainage behavior, what will flows to upstream consolidated nodes, and you can see that's transferring from the Picasso all pipes network, that extended network, to itself, but it's distributing to upstream nodes. And if I want to just take the flows from the Picasso all pipes network down to the local hydraulic model network, I'll need to add one more, which is all pipe nodes to LHM nodes. And that gets me to the LHM network. And then I can just go press the run button, and the simulation will run, and then I can go and view the results. So we're looking at the flows at the final destination right now. So we have flow assigned to Picasso 7561, and you can see the distribution of those flows to upstream nodes. And of course, this can be exported to a text file too. Okay, so that's this new drainage behavior that helps to generate base sanitary flows and consolidate the flows to upstream nodes in the network.